The chain rule is a way to derive composite functions. This is the rule for the chain rule. An easier way to do it is using the box method. So we have f of x, and then g of x is inside f of x, and we put f prime on the bottom and g prime on the bottom. So g of x goes inside f prime, and then you multiply it by g prime. And we'll be using this shortcut for all of our equations. Let's get started!
Our first example is sine 3x. We start by splitting it into the outer function and the inner function. The outer function of sine 3x is sine x, and the inner function is 3x. Now we integrate both the outer and the inner function. The derivative of the outer function sine x is cosine x, and the derivative of the inner function 3x is 3. Next, we plug in the original inner function to the derivative of the outer function, which is cosine 3x, and we multiply it by the derivative of the inner function 3. So we get cosine 3x times 3, or 3 cosine 3x.
Our next function is 15 cos 2x squared. So we need to find our f of x and our g of x. So here the f of x will be cosine x, and the g of x will be 2x squared. From here you're going to find the derivative of each function. So that means cos x becomes negative sine x, and 2x squared becomes 4x. Now you want to plug in 2x squared into your f prime function and then multiply your g prime function. So that's going to look like this: negative sine 2x squared times 4x. And this can be rewritten as negative 4x sine 2x squared. So from here, the last step would be to bring the 15 from above all the way down and multiply it into this function. From here, we're going to get negative 60x sine 2x squared.
Our next problem is sine squared of 5x cubed plus 3x squared plus 2x cubed. So the first thing to notice is sine is squared, which means we first have to use product rule. And hopefully you've already learned product rule, but if you haven't, that's okay. Just know that the derivative of sine squared is 2 sine x cosine x. Now we're going to use the chain rule. So we'll notice that the outside function is sine squared, and the inside function is 5x cubed plus 3x squared plus 2x cubed. So let's set up our shortcut box with f of x and g of x. So one thing you can notice is that there is another chain rule taking place. So we have two chain rules. So let's do this one first. This is going to be x cubed as our outside function, and the inside of the parentheses part as our inside function. So we're going to set up our box, and then we'll put the derivative of each function under that. And then we put g of x inside f prime of x, and we times it by g prime of x. So that's going to be 3 times 5x cubed plus 3x squared plus 2x squared times 15x squared plus 6x plus 2. So now that we know the derivative of the cubed function, we can put that over there for the whole inside function derivative in our box shortcut. And then we'll put the derivative of sine squared x under that as well. Then we'll just continue to follow the chain rule as normal. So we're going to put g of x inside of f prime of x, and then we'll multiply it by g prime of x. And we end up with this really long and complicated answer. But if you understand how the chain rule works, you should be able to do all of it with little error.
So my equation is natural log of root e to the power of x squared plus 1. So first we're splitting up the function as the inside and outside function. The outside function being ln x, which is the derivative of 1 over x, and then the inside function is root e to the power of x squared plus 1, which we can't find the derivative directly, so we have to split it up once more. Outside and inside function, root x, and then e to the power of x squared plus 1, easily finding the derivative of root x as 1 over 2 to the power 2 root x, and then e to the power of x squared plus 1 is split up inside and outside as e to the power of x as the outside function and x squared plus 1 as the inside function, and then we're substituting e to the power of x into x squared plus 1 into e to the power of x, multiplying by 2x, and then substituting that into the second split we made so we can find the answer of e to the power of x, derivative of e to the power of x squared plus 1. And then again, we're substituting e to the power of x squared plus 1 into 1 over 2 root x, and then multiplying it by 2x times e to the power of x squared plus 1. Oops, I made a little mistake there. So here I'm doing it. And then finally I take this answer and put it into the first chain rule we did to find the derivative of root e to the power of x squared plus 1. And then finally I'm subbing in root e to the power of x squared plus 1 into 1 over x and multiplying it by the 2x times e to the power of x squared plus 1 over 2 root e to the power of x squared plus 1. And this will give us an unsimplified version of our answer. And finally, I simplify our answer.
And we get 2x times e to the power of x squared plus 1 all over 2 times e to the power of x squared plus 1. And by cancellation, we just get x.